Welcome to today's session on using evidence-based practices to teach mathematics. We welcome Dr. Karen Fries from Francis Marion University. She is a former elementary special ed teacher from Charleston County. She taught children with autism and then became the math resource teacher for students with learning disabilities in math. She is currently an associate professor of education at Francis Marion University and just began her 8th year. Her research involves the use of evidence-based practices to teach math to students with learning disabilities or autism and active learning strategies as a tool for inclusion for all students. She teaches courses on the Introduction to Exceptional Children, IEP and lesson plan development, math methods for students with learning disabilities, and the accompanying practicum, and overall methods for teaching students with learning disabilities. Welcome, Dr. Fries.
Thank you. I'm so excited to be here. Hi, everybody. I'm really happy to be here today to talk about math with you. Some of you, I know you might be shaking your head saying, oh, math, oh. And if you respond that way, think about what your students feel every time you say it's time for math. Think about especially those students who have learning disabilities in math or who might struggle or who might be at risk at math. So if there's anything, that I can present to you that you can then present to your students to ease their dislike, I guess, of math, then I will consider this a successful day. So I wanted to start off with just a little bit of background, kind of some background knowledge, and to make sure that we are on the same page as we move forward together, making sure we have the same language and that we're talking about, if I say explicit instruction, you know what I'm talking about. I also have some strategies and practice to share with you all, and then some examples. I tried to incorporate as many virtual examples or examples that could be done, in a virtual environment as possible. There's not a ton of research out there yet, but I guarantee you in about 6 months or a year from now, you're going to see a lot of research about what works virtually, to teach students math who have learning disabilities. So, but for now, I'm just going to go kind of with what I have, and I have some jokes, I have some trivia, and I also talk about math for you all. I did present for TASK over the summer, and I guess my jokes were so good that they just wanted me to come back. So I'm really excited to be here, and we'll go ahead and get started. How come 4 never asked out 5? Because it was too squared. You all, these jokes are bad. I'm just going to warn you, they're not good, they're bad. But if you chuckle, maybe your students will chuckle, and maybe that will help get them engaged in math. There's more, I promise. They might get better, they might get worse, depending on your take on my jokes. So I wanted to talk about, again, starting with some explicit instruction and kind of what that means. I've heard of it as I do, I, the teacher, we do together, you do, you as the students. So it also is called model, lead, test, or, watch me, watch the teacher, work together with teacher guidance, and then work independently together, independently together, but without teacher guidance, and then working independently. So it's very teacher directed, especially at first, which if you think about, when we're introducing our students to some new skills and concepts in math, we need to be really direct and we need to be really explicit with them, right? Especially those students who struggle. They're not going to pick something up if you just say, oh, go to page 75 in your textbook. So we want to be really clear and really explicit with them, and kind of talking about planning, how it ties in with explicit instruction. Just very quickly, you want to write short-term objectives, lesson objectives that lead to the accomplishment of IEP goals. Decide what skills need to be taught, in what order. Think about how you're going to access their background knowledge, how you're going to make sure they have those prerequisite skills. Use concise, consistent language and precise language, right? When we're talking about math, we want to make sure we're using precise mathematical language. And I'll come back to that a little later on in our time together. You want to plan to include some examples and non-examples, right? If you're teaching what a circle is, well, you want to teach them what a circle is not also. And you want to prepare practice problems, include review problems, create a data collection system so that you can monitor your students' progress. I do want to show you, this is from a textbook called Explicit Instruction. I think it's called What Really Works. for students with learning disabilities. And I use it in one of my grad classes, but there's one math lesson in there and it's about algebra, it's about parentheses. So I thought it would be appropriate to share. And I know it's kind of, it's a lot of words because I'm going to show you kind of just pictures of the whole lesson, but I wanted you to have a record of it, and if in a couple of weeks you're thinking about, oh, what did that lady say? What can I use? I wanted you to have the record of this lesson to give you an example, again, of what an explicit instruction lesson might look like. I did just take pictures of the textbook because I always get nervous during presentations that something's going to not work or this is going to go wrong. So I just have pictures of the textbook. So I apologize that they might not be, some of the pictures might not be super pretty. But you want to think about the group you're teaching. Okay, in this case, it's 8th graders in a beginning algebra class. Think about their prior instruction, the skill to be taught, the goal of the lesson. Usually it kind of relates, right? The goal and the skill, students will learn the first step in the order of operations, and the skill is using the first step in the order of operations. So they really are aligned. You want to think about the learner goal. Okay, they're going to think about parentheses, exponents, multiplication, addition. And then, you all probably know it is, please excuse my dear Aunt Sally, or PEMDAS, which I will refer back to a little later on. And their prerequisite skill is that they can evaluate a simple expression. So you want to think about how you're going to gain the student's attention. Maybe it's with a bad joke, or saying something like, very explicit, right? Please put all of your materials away except your math log, a pencil, and your math book. Look up here, right? And I used to tell my students that. I would even say to them, put your pencils down and watch me. It's my turn. So then you're going to state the goal, the relevance, okay? Very explicit, very direct and specific. You're going to review these critical prerequisite skills with them. And you're even going to say, but first, let's do a little review or something like that, right? And some of you are probably doing this, and some of you might say, oh, yeah, I haven't done that in a little while. I haven't done the attention, we call it in elementary and early childhood attention getters, but gaining their attention in whatever works for you and your students. Okay, so again, let's look at the definition of expression. Again, we're still reviewing those critical prerequisite skills. Sorry about the down here. That's all I had to cover up the other part. So you're going to display these on a transparency or, on the whiteboard in Zoom or whatever you're using. And you're going to ask them, they're going to on your paper, write the items that are expressions. And then you're going to ask them why. We're still reviewing, right? We're still reviewing those prerequisite skills. We haven't gotten to today's lesson yet. Then, you're going to go through this. Wow, you've really mastered these concepts. Let's learn more about expressions. Okay, and so then in the body of the lesson, this is where you get into that modeling. I do it. So you're going to write this on the board, on the transparency, again, whatever you have in front of you. Look at this as an expression. When an expression contains more than one operation, parentheses can be used to show which, I'll have to minimize myself, I skipped ahead, y'all, I'm sorry. Which computation should be done first. So we're going to look for the parentheses, right? Very explicit. What is 6 plus 3, everyone? 9. Great. You're going to write 9. After I've done the operation inside the parentheses, I can do the remaining operation. Everyone, what is 5 times 9? 45. The value of this expression is 45. So you broke it down for them. You said, here's what I do first, right? You're watching me. Here's what I do first. You get them involved a little bit with the, what's 6 plus 3? What's 5 times 9? Okay, then you're going to write the expression again. You're just going to change the parentheses. Look at this one, 5 times 6 plus 3. Same numbers and operations, but the parentheses are in a different location. First, we do the operations inside the parentheses. So you're still modeling. What is 5 times 6? 30. Great. Now I can do the remaining operation. What is 30 plus 3? Notice the expression has a different value when the parentheses are in a different location. And then there's one more model as well, 63 minus parentheses 4 minus 3. Okay, so then you're going to move into the prompted or guided practice, also known as we do it. So let's do some together. Let's do some problems together. Please stay with me so we can do these items correctly. And this is where you want to make sure that you're guiding them. You're not just saying, okay, go ahead, be free. You're guiding them. You're working together with them so that you're sure that they are getting it and that they are correct. And you're not just, setting them free before they know what's going on. Okay, so you'll go through all this. This is your guided practice. Okay, there's a little more guided practice over here. This top paragraph is the same that was just on the other page. So sorry about that. And then you will write, 15 minus parentheses 9 plus 6. Write this on your paper. Put your pencil down when you are done, right? So it's you do one step, put your pencil down. Let's talk about the next step. What do we do first? inside or outside the parentheses, good. Now you can find the value of this expression. You can move around the room, you can monitor what they're doing, and then you'll write the answer on the transparency and have them check their work. Okay, so then you'll do a few more as you see up here, a few more examples. So you'll do, 15 minus 9 plus 6, 35 minus 5, minus 4 plus 2, and then 9 plus 16 minus 16 minus 18. Copy this expression and find the value of the expression. Don't forget parentheses first. Terrific. Then you're going to move into you do it, or the independent practice. And you, in this case, is the students, right? So, okay, I want you to, and this part to me is really, really important. And I tell my students this all the time. I want you to go ahead and do problem A. Put your pencil down when you're done so I can make sure you have it correct. Because typically what happens is what? We give students a worksheet of 10, 15 problems. We say, go ahead, but we never check to make sure that, and some of you might, I'm sorry. When I was a teacher in K-12, that was the one thing I always forgot was to check, as they're moving into the independent practice, you want to make sure they're doing it correctly so they don't just continue on the worksheet going incorrectly. So this is what I tell my students, do problem A and then put your pencil down. Wait for me to come and check before you can move on or before you move on. So that's really explicit, right? Really, one problem, put your pencil down. I'm going to come check. Then you can do the rest. And then the closing of the lesson, you want to make sure to include the students. Today, you learned the first step in an algebra strategy called the order of operations. We do the operations that are inside the blank, everyone, parentheses, yes. So involving the students in the closure, previewing what you're going to talk about tomorrow. Tomorrow, we will learn about the second operation in the order of operations, exponents, and then your independent work, their independent work. Please open your algebra book to page 5, complete the items in set A. We will check your homework at the beginning of class tomorrow. So virtually, you could say, okay, your homework is, or your independent work is page 5, and we will go over those first thing in the morning or first thing, that we have our class the next time we meet. So that was explicit instruction. Another thing that I wanted to talk about, another practice, another way to teach students or things to think about are using high leverage practices in special education. This is a fairly recent guide or a booklet, I guess, that just came out, maybe 2017, but sometimes my dates say weird things. So there's 22 high leverage practices in special ed, and they're really valuable for all teachers. So if you're on here and you're not a special ed teacher, these practices are valuable for you as well. The practices are in the area of collaboration, assessment, social, emotional, and behavioral practices, and instruction. So just a few examples. Collaboration one, collaborate. Oh, I keep doing that. Collaborate with, sorry, y'all, the green bar is right over it. There we go. Sorry. Collaboration, high leverage practice number 1, collaborate with professionals to increase student success. You want to do that regardless of if you're special ed or gen ed, right? You're all working towards the same goal of increasing the success of your students. So you might need to work with others. You might need to work with paraprofessionals, gen ed, special ed, related services providers, everyone who can help to make the student be more successful. Okay, there's some assessment, high leverage practices. And look at this one, instruction. Use explicit instruction. That's the high leverage practice. That's why I just showed you about explicit instruction. And then also using strategies to promote active student engagement. And this is something that I'm also really kind of passionate about, using active student engagement, especially in an area like math, right? Where it could be so easy to just kind of lecture and, have them sit, but try to think about ways that you can get them involved and excited about math. I know excited might be a stretch, but maybe with some jokes or some trivia, maybe you might be able to get them a little more excited about math. Okay, I also want to talk about Universal Design for Learning, or UDL, and this is a way that allows your students to get engaged in different ways, in ways that work for them, to present how you present the information to them, in ways that they might respond to, and also in representation. So how can you allow students to show you what they know? So thinking about engagement, some students might like bad jokes. My undergrads, by the end of the semester, they like my bad jokes. I'm not going to lie. Or maybe they just feel bad for me. That's okay too. Some of them might really like working with a partner or a small group, but some of them might really prefer to work by themselves. So maybe you could give them some choice. For this assignment, you can choose if you want to work with a friend or if you want to work independently. I know virtually, it might be a little harder, but there are ways that students can collaborate and work together virtually. Maybe giving them some choices, again, like I just talked about, and I'll mention choice again in a little while. So presentation, are you going to do PowerPoints? Are you going to do lectures, podcasts, textbooks, videos? What will your students respond to, and what will help them be more engaged and excited, especially about the dreaded math? Okay. And what about, again, allowing them to show what they know? Well, maybe they could write a story, even a math story. They could act out a skit, draw a picture, do a paper test, oral presentation. Some students really, really hate presenting orally, and they would way rather write a paper, right? Or, or take a test via paper, something like that. So thinking about how you can kind of give them options. These are just some clips I found. If you do have time, I especially really like this one. It is in a secondary, I want to say science class, but she gives them on the whiteboard, she gives them options. Okay, you all have the same task. You can do it this way, this way, this way. You can read the textbook. You can go online and read an article that I have there. You can go on this website. It's really interesting how she divides it up. And again, this is just a little graphic. So representation, providing alternatives for accessing information. So how are you going to present the information? So you could use advanced organizers, graphic organizers, stuff like that. There's also representation. Do they need a keyboard instead of a pen to complete a writing assignment? Something like that. And engagement, maybe using money, right? Will help them with math. Maybe instead of the play money, maybe use real money, as long as you tell them that you need it back at the end. Culturally significant activities, stuff like that, whatever you can do to get them engaged. And there's just a list of some possible interventions that might be helpful for some of your students. Oh boy, it's time for jokes. Just one. Why should you worry about the math teacher holding graph paper? Because they're plotting something. Come on, it's pretty good. And the wolf thing is a little scary, but I found it and I thought it was perfect for the joke. So trying to get you engaged, right? I'm being a little cheesy, but maybe a little funny. In my world, it's funny. Y'all's world, probably not, but I think I'm hilarious. So you want to think about, again, getting them engaged. That got you engaged. That would be a perfect segue into, today we're going to learn about plotting coordinates or, plotting points. So some other things we want to think about is some strategy instruction for middle and secondary students. If you have time, this article, ldonline.org, has a lot of really great suggestions in there as well. So some strategies, PEMDAS. We talked about that, right? That explicit instruction lesson from the beginning was about PEMDAS. That particular lesson was only about the first letter, the P, the parentheses, but, you could do similar lessons for the rest of the letters. Whew, that was a lot to say. So PEMDAS, FOIL, things like that, first, outer, inner, last, right? You're probably using some of these strategies. Vocabulary maps. I'm going to show you what these look like. Vocabulary maps, concept diagrams, FRAYER model, and the keyword and peg word method. So here's a basic vocabulary map. What you do, you put the term in the box where it says vocabulary term, provide the definition, you use the words or the term in a sentence, and then you come up with a visual. So you could do something like this really with any content area, but especially with math. And what I used to do when I taught my students about this vocabulary map, I would do the first one, I would model that for them. Then I would have them work with a group or whoever was kind of around them, kind of some guided practice for this middle one. And then the last one, I would have them come up with a term on their own. And it could be, from whatever content area you're currently teaching. But something like this works really well with math because it's pretty straightforward, right? It's pretty basic: vocabulary term, definition, sentence, and visual. Okay. So then you could also use something like a concept diagram. So here's where you would put the concept, kind of the smaller concept. And here is where you would put the overall or the larger concept. And I'll show you a completed one in just a second. You would put some keywords over here, characteristics that are always present, sometimes present, and never present. And then here you would explore examples and guess what? non-examples, right? Going back to those non-examples. We want to make sure we're showing students what a math concept is and what it is not. Okay, then you will also practice with a new example and tie down a definition. I did have a math one somewhere, but I couldn't find it. So the one I have now is about persuasive writing. I know that's not math. I hear you, but it's the best that I could find. So I do apologize about that. So the persuasive writing is the concept. Written document is the overall concept. Here are some key words. Here are some characteristics that are always present, sometimes present, and never present, right? Like a topic that cannot be debated. Well, that can't really be present in persuasive writing because you need to be able to persuade something. Okay, here are some examples. Here are some non-examples. And here is a definition that they came up with. Okay, but again, if you just search for concept diagrams, math, you might be able to find some. And again, can't find the one that I had completed. Okay, another thing you could use, another strategy is the FRAYER model. And what typically happens with this is I show this to people and they say, oh yeah, I use that. I just never knew what it was called. So the FRAYER model looks like this. Okay, and some of you might say, oh yeah, I've used that before, or something kind of that looks similar to this. So it's defining the term, describing its essential characteristics, providing examples of the idea, and offering non-examples of the idea. All right, so you would put the term here in the middle, the definition here in the student's own words, facts and characteristics, examples, and our favorite, non-examples. All right, so here's a completed one. Here's a quadrilateral is the term. Here's the definition in your own words, some facts, characteristics, examples, and non-examples. Think about your students who might struggle with handwriting, or maybe some of your, your younger-ish students. Maybe handwriting isn't really their forte. Maybe let them draw pictures of what examples are and what examples are not, or what are non-examples, I should say. So they could draw a square, a rectangle, a trapezoid, a rhombus. They could draw all of these things to show what a quadrilateral is not. Okay, another example, parallel lines, going back to that. Here's the definition, facts, characteristics, examples, and non-examples. So you could give your students a choice. Hey, I'm going to give you some terms, and you can complete or create either a vocabulary map that we just showed a few minutes ago, right? You could do a vocabulary map, you could do a concept diagram, or you could do a FRAYER model. That's something you could do virtually, show them how to do all these things and then have them choose which one kind of they like the best. It's the same content, right? They're getting the same stuff, but you're using that universal design for learning to engage them in whatever they like. Maybe one of them likes the look of this one, it's this FRAYER model better than the vocabulary map. Great, let them choose. Okay, now it's time for a little trivia. All right, so I want to test your Disney character knowledge. I want you to identify, and you don't have to write it or anything, you don't have to tell me, which one is Chip and which one is Dale from the picture below. Well, ready? I'm going to blow your mind. Chip is the one who has a little nose like a chocolate chip. So now you'll always remember Chip has the nose like a chocolate chip. Full of knowledge, people. Trivia, jokes, I got y'all. All right, so we want to talk about mnemonic strategy. So that was a type of mnemonic strategy, right? Keyword. So this is, or these are words that sound like the concept or idea being taught. Usually a visual is used in the description. You would model it. Again, going back to that explicit instruction. Today we're going to learn a new concept. We're going to talk about perpendicular. We're going to talk about perpendicular, okay? So you would model the concept, you'd show the relationship between the concept and the key word, a word that sounds the same. For example, the word perpendicular sounds like purple dictionary, so you might draw a purple dictionary on a shelf. Hello, kids. My name is Purple Dictionary. I sit on the bookshelf at a 90-degree angle. The purple dictionary is perpendicular to the bookshelf. So even if your students don't remember what perpendicular means, they might remember this picture, right? They might remember a purple dictionary as they're taking a test or as they come across this word, and they're going to say, oh, I remember what perpendicular is. It's a purple dictionary, and that will give them that visual that they need to say, oh, I know what perpendicular is. Okay, I can answer this question. The purple dictionary is sitting on the shelf at a 90-degree angle. It is perpendicular to the bookshelf. Again, getting that, getting that visual in their mind. Another one, parallel lines, pair of elves. So lines that are the same distance apart and will never intersect. The pair of elves are the same distance apart and will never intersect. And you can go back to, oh, intersect means, crossing, like at an intersection. If they're parallel, they're never going to run into each other. They're just going to run right next to each other until they deliver their packages. The pair of elves are on parallel lines. And yes, also a little tricky to say. But those are some examples of keyword. Okay, I have another little joke for you. See, I gotta keep it moving. Why was 69 afraid of 70? Because they had a fight in 71. Hilarious. Maybe not, but your students might find them just a little funny, maybe just a little, enough to get them engaged and interested in whatever you're going to say next. All right, so now I want to talk to you very quickly about a specific student named Ebony. And Ebony is an 11th grader who's been receiving special education services since 5th grade. Throughout the year, she has made steady growth in most academic areas. However, she still struggles with reading comprehension and math. With recently increased academic requirements needed for her graduation, Ebony receives the majority of her instruction in general education classrooms. She is frequently frustrated with the quick pace and language demands of her classes, especially in math, right? But she has a strong work ethic and good study skills. Okay, so then Ebony's IEP team agreed that her IEP should emphasize algebra, geometry, and problem-solving skills, all kind of those big things in, 11th grade, right? As identified by assessment data and deemed important for state and district tests. So her, Mrs. Ewing, I think, is her gen ed teacher. And she will provide, Mrs. Ewing is a special ed teacher. She will provide consultative support to Mr. Gunther, who is the gen ed teacher, as needed for developing supports for Ebony, such as cue cards and graphic organizers. The special ed teacher will also pre-teach math vocabulary words using visuals and hands-on activities, or things like the FRAYER model, the vocabulary map, stuff like that. You could make the FRAYER model hands-on too. You could give them especially when you're face-to-face, give them a blank template and give them the terms, or give them the term, the definition, examples, non-examples in an envelope. They could cut them out and just match them to the proper category on the FRAYER model to make it a little more hands-on. So the special ed teacher will, like I said, use visuals, hands-on activities, and then Ebony will maintain a math portfolio with artifacts documenting growth in her IEP skill areas. Okay, so I want to talk about some of these strategies that I'm going to talk about. They relate to Ebony and to kind of her situation. So maybe you're thinking, I have a student like Ebony in my class. What can I do to help this particular student? So there's some strategies for algebra: set, cap, factor set, solve, check, and wrap graph. I mean, there's a lot more, but these are just the ones that I'm going to talk about today. So the set strategy to help Ebony evaluate expressions. Mr. Ginther developed the set strategy, which includes these steps. Okay, here's the problem. S, substitute each letter with its value. Okay, so we're going to say X equals 3 and Y equals -2. So we're just going to substitute each letter. E, execute the operation. Going back to our parentheses, right? What do we do first? 3 times 3 times 3, 3 squared, right? So going back to our order of operations, and then try the problem once more to double check. And this would be something you would teach very explicitly, right? Today, we're going to learn a new strategy to help you evaluate expressions. Watch me, we're going to go through it. I'm going to go through it first. We're going to do some together, and then you can do some. Okay, so that is the set strategy. And here are the pre-skills that the teacher covered and reviewed beforehand, like we talked about at the beginning of our time together, reviewing that prerequisite knowledge and that background knowledge. Okay, the next one is the CAP strategy. So this is for solving basic algebra problems. And again, today, we're going to learn a new strategy for solving basic algebra problems. This is the CAP strategy. Everyone, what is this strategy? the CAP strategy, right? So the steps include the following: combine like terms. Okay, and you would show them examples. You would model a couple, you would do some together with them, and then you could set them free for independent practice and or homework. Okay, ask yourself, how can I isolate the variable? You're going to teach them that. And then P, put the values of the variable in the initial equation and check to see if the equation is balanced. Again, modeling, think alouds, all these things that you all are probably doing, but just being really thoughtful and really specific about what you're saying to your students. Okay, use many different examples, operations, and variables so that your students can generalize, oh, well, that's not the same operation we used yesterday. Oh, but that's okay. I can still, generalize this strategy to a different operation. The next strategy is the factor, set, solve, check. Whew, I always have to think about that one before I say it. So this one involves solving problems that require factoring. Okay, it's a 4-step process. Again, you would teach it very explicitly. F, factor the equation. S, set each factor equal to 0. Okay, so here's the examples. Solve each factor for X, and then check. Okay, so you're going to solve it here, true, true. The solutions are -2 and -1. So you factor, set, solved, checked. Another one is the wrap graph strategy. I've also used just the wrap strategy for reading comprehension. So this just kind of builds on that a little bit. So you're going to read the problem, ask yourself, what number can I plug into X to solve for Y? Okay, example, I will plug in 0 for X. So then if X equals 0, then Y equals 0 plus 1, or when X equals 0, Y equals 1, right? So you're asking yourself, and again, you're teaching your students. So you would do a think aloud. I'm going to ask myself, and I always used to say, self, what number can I plug in? And my students thought that was funny. Yours might not, but mine, I think they were really just laughing at me, but that's okay. And then P, plug in 4 more numbers for X to solve for Y. Again, you want to show them it doesn't, X is not always going to be 0, right? So I'm going to plug in 3 for X. I'm going to keep going with 3 more numbers. And then you could have them graph the coordinates using the value pairs that you found for X and Y. Going back to that joke about always plotting something. Okay, some other strategies. We can talk about strategies, or we're going to talk about strategies for geometry. And again, there are a bunch of strategies out there. These are just the ones that I happen to find. Oh, this one's a good one. Get ready. What do you call a ruler, a protractor, and a compass all hanging out together? It's a good one. Weapons of math instruction. Get it? Come on, it's funny. And the little graphic, come on, that's kind of cute. I was very proud of finding that. So one strategy is the 3-column note-taking format in geometry. So you can, this one happens to be about triangles. You could list the triangles over here, provide description of the triangles right here, and then a picture right here. Just a different way of, using kind of a FRAYER model or vocabulary map, something like that. Just a different format to help them learn, okay, here's an equilateral triangle. Here's a description. Here's a picture. Here's a scalene triangle. Here's a description. Here's a picture. Just that visual and that organization to help your students try to differentiate between the triangles. So there's also some mnemonics for geometry. So at 90 degrees, one angle is tight. We will remember it is right. Perimeter is the sum of the lengths of all sides. Area refers to units needed to cover the inside. And we're going to talk about area in a few minutes. So that would be a little mnemonic that you might want to introduce to your students. Some other strategies when they're ready to use things like only formulas. And again, we're going back to Ebony and Mr. Ginther. And I think I called him Mr. Gunther, but it's really Mr. Ginther, excuse me. So read and understand the question. Okay, what is the area? Remember the formula and recheck your work. So those are the 3 R's. And again, you would teach them very sequentially, very explicitly, and then have your students work with you for some guided practice and some independent practice. You could use geoboards, right? Which I'm going to show you in just a second. There's another one. This is called the what for strategy. So what is the given information? What is the question asking? What do I know? And what is the missing value? So you would look at the picture, you would, okay, 3 of the interior angle measures are given. What is the question asking? What is the measure of the 4th angle, right? It gives you 3 angles. You need to figure out the 4th one. What do I know? I know the interior angles of a quadrilateral measure 360 degrees. What is the missing value? So you could solve, right? You would teach them how to solve. Okay, I'm going to add up the other 3 angles, and then I'm going to subtract from 360. My missing value will be the answer, and I'll just put it in degrees. Okay, another way, what is the given information? What is the question asking? What do I know? And what is the missing value? And this was for similar figures in geography. Okay, so there's some geoboards. This I just honestly just Googled virtual geoboards, and this is what came up. There are some websites out there that you could have your students use virtual manipulatives. There's also illuminations if you use that. And this one, it was pretty cool. You could balance, you could build your model, and then you would have to balance it to make sure it was the same on both sides. So that was pretty interesting as well. Okay, some other strategies are for problem solving. We know problem solving is a big thing in middle and high school, right? So the STAR strategy is a mnemonic strategy that uses manipulatives. So S, you're going to search the word problem. Read the problem carefully and ask questions like, what do I know? And what do I want to know? Write down the facts. So you're searching the word problem and writing down the facts. T, translate the problem. Translate the word problem into an equation. Translate the equation into a picture or use counters, right? And you might think, oh, my students, they're too old for manipulatives. Not really. And you're not going to give them, like teddy bear counters like you would in early childhood, but there are appropriate manipulatives for middle and high school students. Popsicle sticks. I'm going to show you one in a few minutes about popsicle sticks. Those are kind of just generic manipulatives that are beneficial for everybody. A, answer the problem, and R, review the solution. Okay, another strategy, you're going to read the problem aloud. Look, and I'm actually going to just go to the next slide. Okay, read the problem aloud. You have 7 toy cars. You get 2 more. How many cars do you have in all? Look for important words and circle them. Okay, well, I'm going to circle them. I'm going to say I have 7 toy cars. Well, I think that's pretty important. You get 2 more. I'm going to circle 2 more, not just 2, because I need to know that my 7 is increasing. How many cars do you have? What else is important? I think in all is important. Whoops. Pretend the circle goes that way. There you go. Okay, then you're going to draw some pictures. So we're going to pretend I already have 7 cars, and I'm drawing 2 more. I'm adding 2 more. Write down the math sentence. I have 7 toy cars. Okay, so 7 plus, how many more did I get? 2 more. And my answer equals 9. So that's about how bad my handwriting is in for real life. So I apologize. But that's a very simple strategy to teach your students. There's another one, the SAW strategy. Set up to solve. All right, that is our S. Attack the problem and then wrap it up. And again, you would teach this very sequentially, very specifically. I'm kind of going a little quickly. I know that because I know that my time is limited and I still have a lot more to tell y'all. So, but you'll have this record, you'll be able to come back to the PowerPoint whenever you want. Another thing to think about is the graduated instructional sequence, that CRA, concrete, representational, abstract. So concrete, would be actually holding 3 apples or whatever you're talking about, actually giving the students apples or oranges or whatever that they can hold and, manipulate and have in front of them. Then the representational or pictorial depictions would be maybe 3 tally marks, or they could draw 3 pictures of apples. I'm not going to try to draw because that would just be no. So they could draw tally marks, they could draw pictures, something that represents those 3 actual apples. And then the next step is the abstract depictions or problems presented in symbolic notation or written form. So this is where they say, okay, I'm going from 3 apples, 1, 2, 3. Okay, now I don't have the apples in front of me. I'm going to draw 3 tally marks, 1, 2, 3. Oh, now I just know 3 means 3, right? Writing the numeral 3. That's that abstract when there's nothing in front of them, but they can say, oh, I know what 3 means. Okay, so again, you want to teach these stages using explicit instruction as well. Sorry, I'm trying to get rid of the pen. You want to use explicit instructions, modeling, guided practice, manipulatives, algebra tiles, something like that. There's another strategy, solve it, that is say, ask, and check. Say the purpose, ask what is required in that step, and check to ensure that that step is completed. A couple other things you want to, again, CRA, you want to think about using precision in math language. And what I mean by that is this right here is 432, right? You don't want your students or you to say 432. You want to make sure you're being precise. And we talked about that at the beginning of the presentation, being precise with math language. So we want to make sure we're saying 432. 432, not 432. You know, even when you're talking about page numbers, oh, open to page 432. Open to page 432. It really helps with that place value and that expanded notation, which some of your students might still struggle with, even though they're older, and those are typically, you know, more elementary and early childhood skills. Some of your students might struggle with some of those concepts. Pose real world problems, draw connections as much as you can, thinking about how you can engage students. Again, we talked about that at the beginning with universal design for learning. Think about how you can present or represent math concepts to your students to increase their understanding. You know, going back to that universal design for learning, teaching math language, mnemonics, graphic organizers, you know, this all kind of goes together. Anchor charts, anchor activities, stuff like that. Thinking of output, thinking of ways for them to express their new knowledge. You know, they can use manipulatives, fraction circles, technology, games, scaffolded supports, whatever works for you and your students. And assessments, you know, they don't always have to be formal, right? They can be very informal assessments. Give me a thumbs up, give me a thumbs down. Use concept maps or those vocabulary maps that we talked about, or a FRAYER model. That would be a perfect assessment after you had talked about some terms. You know, maybe give them the term in the middle and then they have to fill out the rest. It'd be a perfect assessment for you. Okay. Oh, I got a couple more. Why was the math book so sad? Y'all have probably heard this one. Because it had a lot of problems. Why do middle school girls walk around in groups of 3? Because they can't even. You know, all those middle school girls, they always say, oh, I can't even, right? So it's because they can't even. So a couple more mnemonics, LAP, which is for adding and subtracting fractions. So you want to look at this, or you want to teach them to look at the sign, ask yourself, are the denominators the same? And then pick the process for the fraction type, which you would have already taught them, right? You already would have taught them how to add fractions, how to subtract fractions. This is just a way where they can say, which process do I need to choose? Okay, and then there's a solve strategy for problem solving. Study the problem, organize the facts, line up a plan, verify your plan with action, and evaluate your answer. So kind of solving the problem and checking the problem. Okay, some other couple of things I wanted to show you before I get into some more virtual things. Just some different types of word problems and how you can graphically represent those word problems. So there's one that's called a change problem. David had 21 video games. Here's a beginning set. He sold 7 games to the game store. He now has 14 games. And obviously you could leave one of these blank. You know, he had 21 games. He sold some games. Now he has 14. You know, solve for how many games he had or how many games he sold, excuse me, something like that. This one is a group. So Alicia had 2 adult dogs. Her dog had 5 puppies. All of that is kind of the smaller set, right? The dogs and the puppies. And now Alicia has 7 dogs in all together, something like that. And that would be your larger set. Then there's also a compare. There's a compare set, a different set, and a referent set. Okay, again, in any one of these, as you see here, any one of these could be blanks. And again, you would teach them very explicitly how to work through those different types of problems. Okay, I wanted to spend some time. Oh, sorry, I hit the arrow and I didn't mean to. I wanted to spend some time talking about discussion questions, and especially in an online environment or in a virtual environment. You know, you want to think about wording questions so that they are open-ended, right? Because if you pose a question that's just right or wrong, or the students can look up the answer, you know, once the first few students post their answers, the other students don't have anything else to do but just copy what they already said, right? Yeah, same as what she said, same as what he said. So thinking about open-ended questions, which, you know, might be a little unnatural in math, but there are a lot of starters out there, a lot of prompts out there, and a lot of ways to really think about open-ended questions. What do you think? Why do you think that? How do you know this? Can you tell me more? What questions do you still have? Can you tell me one way to solve this problem? Who can tell me another way, right? Perfect discussion board question for in an online environment or a breakout room or something like that. You know, I want you all to talk about this way. I want this group to talk about this way to solve a problem. I want this way, this way. So lots of options here. This was taken from Ohio State. I am a Penn State grad, so it pained me a little, but it is a really great site. So u.osu.edu/distance education. So in case you want some more information. So again, open-ended questions. questions. You might ask them to give an example of a concept, explain why they think it's a good example. You can use some current events, especially, with the election. That's all about math, right? It's all about the numbers. So thinking about how you could tie in current events or things that are relevant to them to get them, again, more engaged and more interested in math. Questioning, what would it be like if there's only one way to solve a math problem? Taking a position, you could do virtual debates, right? The SAW strategy that we talked about a few minutes ago is the best strategy for problem solving. Do you agree? Do you disagree? Why or why not? And you could even divide them up ahead of time and say, you're going to be the side that argues for the SAW strategy. You're going to be the side that argues against the SAW strategy. And we're going to have a virtual debate. You could do predictions. Given a math situation, students predict the outcome and explain why. Here's some critical thinking question prompts. Yes, not all of these are appropriate for math or lend themselves to math, but some of them do. Here's kind of the basic levels of questioning. Here are some of the more advanced critical thinking questions. What would it be like if? Can you elaborate on the reason why you chose that strategy over this strategy? Something like that, right? Would it be better if you used the SAW strategy or the SOLVE strategy? Something like that to really get your students thinking critically about math, about everybody's favorite math. Okay, some other ideas. And again, some of you probably are already using these, but I just wanted to kind of have them all in one place for you. Some other ideas are Padlet, where they can make their boards. You could do Pear Deck if you're using Google Slides. That's the only problem is Pear Deck works with Google Slides. But then there's Nearpod as well. So both of these are where you make your PowerPoints a little more interactive. You can leave some blank spaces in your content that they have to then respond to in Pear Deck or Nearpod. You could use breakout rooms for Microsoft Teams, BB Collaborate. I almost said BB-8 from Star Wars. I'm not going to lie. BB Collaborate, Google Meet. You could do something like a choice board. I saw this the other day. I was out in a second grade classroom actually, but they were doing stations and they had choices. So they had the left column, and these were posted on the whiteboard. They had a left column. They had to choose one of those activities, tasks. Then they had the right column. They also had to choose one from those. And then in the middle, there was a must do column. So that could be easily adapted to students in a virtual environment. You give them, and maybe it's not something they do right that day. Maybe give them a week. Okay, don't forget, from your choice board, you have one from the left side, one from the right side, and you have to do the one that's in the middle. Going back to giving them some choices, universal design for learning, getting them engaged, right? Thinking about a way that might be more appropriate to specific students. They might really like to draw a picture, whereas the other person might like to write. So give them some choices. You could do presentations or have your students do presentations and have them submit as a YouTube link. That's what I do with my graduate students. And that way they're accessible to everybody else in your class, or submit as a Google Drive link, whatever works for y'all. So again, I just wanted to reiterate, this is taken directly from the site. Forget about asking dead end or fact reporting style questions and start posting questions that get students to critically think about the topic or to think more deeply about their own thoughts on the topic of discussion. So if you can pose some of those open-ended questions, you can really start a good discussion, even virtually, right? You can really get a good discussion going and keep probing and keep prompting them. Well, why do you think that? Oh, can someone tell me another way? Oh, does anyone have a different idea of how you could solve that problem? Something like that. That's what I did with my undergrads, with my early childhood math method students. We would do stuff like that. There are also some virtual games, and this might take a little bit of work on your part, but you could maybe email. So the game is something like this: I have, who has. Pretty easy to play face to face, right? You just kind of dole out the index cards, and you have to make sure you have all the cards first, because if you lose one, the game doesn't work. So let's say you would start, I have 81, who has 5 times 6? Okay, the next person, I have 30, blah, blah, blah. You would keep going, and the final card would say something like, I have whatever number, who has 9 times 9? And look at that. It brings it right back to you. I have 81. So again, that's why you have to make sure you don't lose any of the cards. But virtually you could email the cards out, a couple of cards to each student, or something like that. And it would take a little bit of thought, but something, and again, you can use this with any content area as well. This is one that I really like, I'm not going to lie, virtual math think boards. So you could, or your students could come up with a solution that can have many questions and problems. This link is an example of a think board, but it looks a little different than this one. So just if you know, or just so you're aware, if you do go into this link, it does look different, but it's also a great idea as well. So what you would do, you would each, if you're face-to-face or virtually, you got to be a little creative, right? You will each get a sentence strip, piece of paper, whiteboard, discussion board, kind of whatever your students have in front of them. And you will write, you being the students again, you will write the answer is, and write your answer. Okay, so example, the answer is 12 dogs left. The answer is X equals 7. So that goes kind of, if you're face-to-face or, kind of goes up here at the top. And then people have to come up with problems or questions that will lead to that answer. Okay, so other students can use index cards, piece of paper, whiteboard to provide a question, problem to the answer solutions. So if the answer is 12 dogs left, the question or the problem might be, I had 18 dogs. I had to give 6 of them away to my friend. I'll take them. How many dogs did I have left? Okay, so maybe in a virtual environment, maybe you could post each answer, that you come up with as a whiteboard or discussion prompt or whatever it's called. I don't use Google Meet, so I'm not super familiar with the term. So sorry if I'm butchering the terms. So a whiteboard or discussion prompt in the breakout rooms, and have your students kind of rotate through each breakout room and come up with a question or problem for each answer. I think that could be great bell work, great kind of classes starting. Okay, I want you to, here's the answer. And maybe you do the answers first. And then, by the end of the week, I want y'all to come up with 3 different answers, and then we'll come up with the problems. There's also TED Ed lessons. I don't know if I just learned about this over quarantine, but if you go here, ed.ted.com, lessons category math, there's all these different lessons, not just math, but I wanted to try to find the specific link to math. And this is what it says on there. Let's begin. Learning to calculate area is one of the most practical and useful math skills you will ever learn, whether on Earth or on another planet. Just think of how engaging that might be, right? That could start a whole discussion. Where, would you like to live on another planet? Why or why not? Blah, blah, blah. That could, you could really go with this. This vocabulary song covers the length and width of calculating perimeter and area with some real life and out of this world examples. So on this actual website, there is a video on the TED Ed page, but I couldn't screenshot the video. It did not work. And then you can subscribe to get emails each day as well, which I still get. I think they have elementary level topics, middle school, secondary, and even higher ed and college. And then there's some options on there: watch, think, dig deeper, and discuss. So you can go into, dig deeper or discuss, and there will already be some questions for you. So I think this is great. I think it's very user-friendly for virtual learning. Okay. And then if you did something like that, you could go right into something like this, which is a very explicit instruction. This is from a book called Direct Instruction in Math. And it would say something like the area of a figure such as a rectangle is the number of squares, such as square inches or square feet, it takes to cover the rectangle. Listen again. The area of a figure is the number of squares it takes to cover the figure. Everyone, what is the area of the figure? And then this is what they would respond. So you would show them this picture. You can find the number of squares by multiplying the number of squares in each row, right? Which is 13, by the number of rows, okay? 4. The number of squares in each row tells us the base. How many squares across the base of this rectangle? You would point, everyone, 13 squares. Good. The number of rows tells us the height. How many rows high is this rectangle? 4 rows. Everyone, 4 rows. To find the area of this rectangle, we multiply the base by the height. What do we multiply to find the area? Everyone, base times height, right? It's a very explicit, it's not advancing. Okay, sorry. So very explicit instruction, direct instruction, and you would keep going. So the equation, base times height, 30 times 4 square feet, 52 square feet. And then you would start another one. Okay, so but it really ties in with that particular TED Ed lesson that I showed you. Okay, there are also a number of a number of manipulatives out there. This one is just fraction bars. They are actually, I have this set, but guess what? If you don't, Oh, you can be very creative and just make them with pieces of paper, sentence strips, whatever you have and whatever your students might have on hand. There's also this, and this is from, I'm trying to read the side of it, the Center for Applied Research and Education. You could just search, fraction bars, and I guarantee you will get some graphics that might be helpful. This is another thing, and I'm so excited about this. I'm wrapping up. I know I'm running out of time, but this one I just discovered the other day, and I think this is just so cool. So if you take some toothpicks, or excuse me, tongue depressors, not toothpicks, because you could not write on those. So you could make your own fraction bars. When one bar is placed over another bar, fractions are formed, right? In this case, it's 3/5. The two numbers at the extreme left indicate the fraction formed, such as 3/4. I think they meant to say 3/5 here, but we're just going to pretend that they meant 3/5. Okay, the remaining fractions are a set in which each member of the set is equivalent. And yes, here they're doing the equivalence for 3/4, but I did it with 3/5. The fraction and its equivalents are formed by putting the 3 bar over the 5 bar, right? So again, just, toothpicks or tongue depressors, popsicle sticks, whatever you want to call them. The fat ones work really well because you can actually write on them. Okay, so you do like that. And then you could say, you could compute with fraction bars, instruct the student to use the bars to add two fractions, such as 2/3 plus 2/5. All right, so they don't have the same denominator, right? So some of your students are probably saying, oh, I can't do that. Oh, it's too hard. I don't know how to do that. Give them bars like this. I guarantee you, and they can even make this with pieces of paper, right? They could take a piece of paper and fold it hot dog style, kind of the long ways, and just, you could explain for virtual, you could explain to them, okay, line it up, start on the left side, start with the number 2, leave a little bit of space, leave a finger's worth of space, put the number 4, whatever, or leave a pencil worth of space, something like that, so that they can make their own. Okay, so you would form the fraction 2/3 by placing the 2 bar over the 3 bar. Then you're going to form the fraction 2/5 by placing 2 over 5, right? Okay, now look at the denominators of each fraction and locate the lowest number that is the same on each denominator bar, right? That least common denominator, lowest common denominator. In this example, it's 15. 15. Okay, 15. Then you're going to just slide the fraction 2/5 over until 6/15 lies directly under 10/15. So now, look, they can see, oh, wait a second. I have the same denominator. Oh, I can do that. I know what to do now that I have the same denominator. So they could add, right? They could add fractions, simply add the numbers on the numerator bars, which would be, I kind of cut this off, sorry, which would be the 10 plus a 6, and that gives you 16/15. Or to subtract, you would subtract one numerator from the other one. In this case, you would say 10 minus 6, and that gives you 4/15. So very cool. I was so excited when I discovered this little easy trick, right? Super easy. Okay, and there's another one. These are the ones I made myself. You're welcome. Told you I had bad handwriting. So 3/5. And you could say, hey, show me an equivalent fraction for 3/5. And they could tell you, oh, 15/25 is an equivalent fraction for 3/5. And you could do this online. You could post these. Okay, somebody else, tell me another equivalent fraction. Oh, 6/10. Somebody else, tell me another one. And I think it gives you up to 8, 1, 2, 3, 4, 5, 6, 8 equivalent fractions. So something that's so simple, popsicle sticks or tongue depressors or a piece of paper, however you can make these fraction bars, these equivalent fractions, I think they're just really, really interesting. Okay, one more thing, also with popsicle sticks, tongue depressors, again, whatever you want to call them. So in this case, we're going to talk about reducing fractions. So they call it, and this is actually from Brad Witzel, who's up at Winthrop University in Rock Hill, so some of you might know him. This is a book I found of his that I don't even know where it came from. So place 3 1-sticks over 9 1-sticks, okay? So our fraction is 3/9. So here are our 3 popsicle sticks over our 9 popsicle sticks. We need to divide the numerator and denominator by the same number of sticks. Let's try by 2. Move sticks together as shown. Since the groups are unequal, then we try to divide by another number, right? So because dividing by 2 left us with an extra 1 in each case. So let's try and divide the numerator and denominator by 3. Move the sticks together as shown. Now there are groups without any remainders. 1 group of 3 over 3 groups of 3. So now stack the 1-sticks per group. Okay, so we're going to just stack them up here, here, and here. We are left with 1 3 1 over 3, or 1/3. So going back, 3/9, that's what it looked like initially, can be reduced to 1/3. I just thought that was so cool, y'all. I'm so excited about these popsicle sticks with the fractions. So I believe that is all I have for y'all. Oh, I have one more joke. Oh, I just gave the answer. I had a hen who could count her own eggs. She was a mathematician. You're welcome. Here are the references. Again, most of them are textbooks, but hopefully you found something that you might be able to learn from this presentation and you might be able to share with your students. Thank you all.